Okay, hi guys. I'm pretty much going to keep going where I left off from the last video, which was this equation here, z to the 4 equals 81i. So we were finding the fourth roots of 81i if we use that language around the nth roots. So I'm just going to go through that example. So we're going to start with z to the 4 equals 81i. Now the first step whenever we do these is we convert the right hand side into polar form. So in this case 81i, that's on the imaginary axis pointing straight up, somewhere up here. So the argument for that is going to be pi over 2 and the modulus is 81. So we're going to make it 81 cis pi on 2. The next step is we're going to acknowledge the fact that there are multiple possible ways to get here. So we're going to add on that 2k pi because we could go round by 2 pi, 4 pi, 6 pi and so on. So that's our next step. Then the third step is we're going to raise both sides to the power of a quarter. So the left hand side, that just cancels down to z and we get a quarter over here on the right. What I've also done here is just combined the argument into a single fraction. So I've just put them both over 2. So to get this over 2, I had to multiply the top and the bottom by 2. So to get that over 2, that became a 4. So it becomes pi plus 4k pi all over 2. And then using de Moivre's theorem, the modulus gets multiplied by a quarter. Raised to the power of a quarter, and then the argument gets multiplied by a quarter. The effect of that, if we multiply something over 2 by something over 4, it's going to become over 8 instead. Now the next step is, we'll just take 81 to the quarter, which gives us 3, which is what we actually predicted on the previous slide. So we're going to have 3 cis pi plus 4k pi all over 8. Now what we're going to do is we're going to consider values of k. So I'm going to start at k equals 0, and then I'm going to do 1, 2, and 3. And I'm going to stop there because I know that there are always 4 solutions for the fourth roots. So I just need to consider 4 values of k, one after the other. I don't have to actually do 0, 1, 2, and 3. I could do 1, 2, 3, 4. I could do -2, -1, 0, and 1, as long as they're subsequent. But it's normally easiest to start at 0 and go from there. So when k equals 0, I'm just going to get pi over 8. So that's pretty easy. When k equals 1, I'm going to get 5 pi over 8. When k equals 2, I'm going to get pi plus 8 pi, so that's going to be 9 pi over 8. And when k is 3, I'm going to get pi plus 12 pi, which is 13 pi over 8. So I can write all of those out. Now I'm just going to do a little bit of simplification. This is, and some people don't even bother to do this step, but technically our argument we should try and get between negative pi and pi. So if you have 9 pi over 8, if you think about it, well, 8 pi over 8 is going to be pi, which is there. 9 pi over 8 is just a little bit further, like 1/8 of a pi further. So if we'd come the other way, if this was 9 pi over 8, if we come back around the other way, that would be -7 pi over 8. Because this point here, which is pi, is 8 pi over 8. Hopefully that makes sense. Again, you don't technically need to do this last step, but it does make it look a bit tidier. And then the last bit here, we've got 13 pi over 8. Well, 16 pi over 8 is a full lap of the unit circle. So 13 pi over 8, we could go -3 pi over 8 and get to the same spot. So that's going to be our final 4 solutions. Now, just like we said in the rules for the nth roots, if I just clear this up, what we're going to do is graph all of those solutions onto the Argand diagram and have a look at what that looks like, because there is that really interesting pattern there what you'll notice is that all of these are equally spaced. There's sort of like a 4 pi jump as you go from one to the next. Sorry, 4 pi over 8, I should say, which is equal to pi over 2. So they should be evenly spaced. So 3 cis pi on 8 is going to be about here with a length of 3. Okay, that's pi over 8. When we do 5 pi over 8, we're going to be about here. Okay, that's 5 pi over 8. When we do negative 7 pi over 8, that's going to put us back right over here. So that's negative 7 pi over 8. Again, these have all got a length of 3. And then our final solution is negative 3 pi over 8, which is down there. So they all have the same length. So they all sort of lie, if you imagine you could draw a circle with a radius of 3, they would all lie on that circle. The other really cool thing is that if we take the ends and join them up, well, in this case, we don't get a triangle, but we do get a square. So, really, I think that's just really cool that when we take the nth roots, we just get this really cool pattern coming up on the Argand plane. So hopefully that makes sense, and thank you for watching.